Alright, let's look at something new here. We know how to take these integrals, very basic of what we need to do in terms of taking an antiderivative plus c at the end. However, these are just with the square root of x, just with x cubed. What if we have something else on the inside instead of x? Well, what we're going to do here is a special trick, and we're going to call it u substitution. And what we're going to do is we need to, here are the steps. First, choose a u. Usually it's the inside of these composite functions. Then what we're going to do is compute du. And then what we want to do is essentially rewrite the integral in terms of a new variable and solve it that way. And then always end up getting back in terms of x. So this was one of the ones that was on that front list of how do we solve those. So what we're going to do is we need to say, what is u? U is usually the inside. In this case, it's, I don't want to say it's obvious because you haven't seen many of these, but whatever is on the innermost part is almost always going to be what your u is. To find du, I need to take a derivative of this thing. The derivative of 7x minus 2 is just 7, but I'm doing it in terms of x, so I need to make it 7 dx. So what I'm going to do is I'm going to rewrite this integral now. This 7x minus 2 we said was u, so now it's u cubed. That's something I can take the integral of. Now, I don't want dx anymore, okay? I need to make it du. Well, what is dx? Dx, if I were to get dx by itself in this equation, dx would equal 7 over, I'm sorry, I've said it backwards, du over 7, if I divide both sides by 7. So I mean this is du over 7. If I rewrote this equation, I'll bring that divide by 7, put the 1/7 out in front, and it's the integral of u cubed du. I can take this integral here. That is possible. I couldn't take it when I know this stuff on the inside, not knowing what it is. So now I can take an integral. Keep that 1/7 out front. The integral of u cubed is 1/4 u to the 4th. And I need a plus c as a constant on the end of integration. And then from there it's just simplifying it. 1/7 times 1/4 is 1 over 28. It is u to the 4th plus c. Now the thing is, I can't keep it in terms of u. I need to plug back in from my original, into my original expression. I need to get it back in terms of x. So to do that, I'm just going to say this is now 1 over 28, and instead of u, I'm going to plug back in 7x minus 2 to the 4th power plus c. Now, I can always go and check my answer by just taking a derivative right back. If I were to take this derivative right back, it would be a chain rule. I have to multiply by 4 first, and I'm going to get 1/7. 4 times 128 would be 1/7. The inside stays the same with a new exponent of 3. Then times the derivative of the inside. The derivative of the inside is 7. Well, 1/7 times 7 just becomes 1. 7x minus 2 to the 3rd power, which is what we wanted to begin with. That's just a way you can kind of see how to check your work. Go ahead and see if you can give this one a try. I'll even help you out with the start and tell you that u is going to be that inside 3x minus 4. So see if you can figure out what du equals and if you can solve it from there. Alright, see how you did? Your derivative of 3x minus 4 is just 3. It's in terms of x, so I want to make it dx. Again, that means that dx would equal du divided by 3. So, as I go to solve this, I should now rewrite it as the integral of u squared, and it would be now du over 3. So 1/3 the integral of u squared du. Now I can evaluate this integral. I need to evaluate it. It'll be 1/3 from the 1/3 here. The integral of u squared is 1/3 u cubed plus c. So that means simplifying will be 1/9 u cubed plus c, but I don't want u. I need it back in terms of x. So 1/9 of 3x minus 4, that quantity cubed, plus c. Alright, let's look at some other ones that we can possibly do. This one we have two different things that we could possibly say being as our u. What I want to look for is one should be the derivative of the other, or very close to it. Well, if I take the derivative of 3x, or x cubed plus 5, I get something x squared. And what's going to happen here is you'll see, if I make x cubed plus 5 my u, and I make du my x squared dx, watch what here. Let's plug in what I know. It would be the integral of, I'll keep that x squared, I can't do anything with that. My x cubed plus 5 is now my u, and it's u to the 4th power. My dx will now be du divided by, it would be 3x squared, I should have put there, I'm sorry. Du divided by 3x squared. And look what happens here. The x squared cancels each other out. So what I'm looking for is one thing, in this case the x squared, being the derivative of the other. And that other, I should say, the x cubed plus 5, is what I want to make my u. That way du becomes this thing I can cancel out. So when I rewrite this, it'll now be the integral of 1/3 u to the 4th du. Evaluate that integral, the 1/3 stays there. It's now going to be 1/5 u to the 5th plus c, which means 1/15. I'm going to substitute back in for u, x cubed plus 5, all in the 5th power, plus c. Alright, and I got one more example here to look at. This one actually will be the easiest of all of them, I think, but give it a try and see how you do. See if you can find your u and your du, and see if you can evaluate this integral. Alright, again, you should have noticed that the x squared, its derivative is 2x. So I want this inside part, the 25 minus 2x, to be your u. That means your du would be a negative 2x. Don't forget about that negative 2x dx. So, evaluating it now, it's the square root of now u. The 2x I'm going to keep right where it is, and dx is now going to be du divided by negative 2x. The 2x's will cancel each other out. I still have that negative there, so it's the negative integral of the square root of u du. I'll simplify that and make it negative integral of u to the 1/2, because we like the 1/2 power better, du. Now evaluate that integral. Negative will stay there. It's now going to be u to the 3/2, which means my fraction in front should be 2/3, plus c. The negative stays in front like it was, and then change it back to the, in terms of x, so it'll be 25 minus x squared to the 3/2 power plus c. And that probably could be simplified, but we're not going to worry about it. That is just all that we need to. We got it back in terms of x. That's all we want. Well, there you have it. U substitution. You'll be seeing a lot of this pretty much for the rest of the year. And we'll talk more about this and how to do it with definite integrals in our next show.